Okay, so let's talk mastication. Food is taken into your mouth and chewed. The incisors and the canines, they're used to cut and to tear food. Your canines usually are used to puncture. If you've ever had to open a bag or something, you kind of with your canines. But these teeth in front, your flat teeth in front, these are basically like a flat blade. They cut through things, okay? Your premolars and molars, like I said, a molcajete or mortar and pestle, they're used to kind of crush and grind. That's why you have that big flat surface. This process of mastication, I said this before, it increases the efficiency of digestion. You're taking these big molecules of food and you're making them smaller, adding surface area for enzymes and acids and things like that to get access to. There's a reflex in the medulla oblongata, and it's influenced by the cerebrum that helps us to chew our food. We have four primary muscles. I just choked on nothing. Four primary muscles that help us with chewing: the temporalis, the masseter, the medial pterygoid, and the lateral pterygoid. Okay, again, P is silent, so don't use pterygoid, it's just pterygoid. So temporalis, masseter, and the medial pterygoid, they're responsible for closing our jaw when we're eating. Okay, all right. The lateral pterygoid is responsible for opening our jaw. And then the masseter, medial, and lateral pterygoid, they're responsible for protraction and lateral and medial excursion. So protraction, remember, is jutting your jaw forward. This is retraction, this is protraction. And then lateral and medial excursion, side to side, okay? So temporalis is the one that's responsible for retraction, for pulling that jaw back, okay? So the salivary glands, as I said, they're not in your mouth. You've got the sublingual, the submandibular, and the parotid, okay? They help to keep the oral cavity moist. They also begin digestion. They suspend molecules in a solution so that they can be tasted. They produce either a thin serous secretion, or they can produce thick mucus secretions, or they can do both. It depends on which one you're talking about. So the large multicellular glands we have are the ones that I just pointed out: the parotid, the submandibular, and the sublingual. We also have small coiled glands, kind of like our sweat glands, embedded in the tissue of our tongue, of our palate, of our cheeks, and of our lips. So we've got the lingual, the palatine, the buccal, cheeks, and the labial, the lips. So we're not just using the bigger glands to get this saliva that we make. We're actually also taking advantage of the fact that we've got the smaller glands embedded in other places. So let's talk about the big glands. The parotid is up here. Okay, it's right next to your ear. If you ever had something that was really sour and all of a sudden it feels like you get a cramp right here and you're like, oh, yeah, that's the parotid salivary gland. Okay. It's a serous gland, and it produces mostly watery saliva. The secretions from this come in by your second upper molar. One of the places that we have issues with plaque is actually where these salivary glands come into our mouth. So we have issues with plaque with our molars. The submandibular, again, it's under the mandible, okay? It's actually kind of more of a half and half mix of serous and mucus. The secretion enter next to the frenulum of the tongue, that attachment piece, but it's capable of making that watery, thin saliva like the parotid, or the thick kind of viscous saliva that you can get from the mucus glands. And then the sublingual, it's also kind of a mix of serous and mucus, and it opens onto the floor. See these right here? the floor of the oral cavity. It's got about 10 to 12 ducts to it, 10 to 12 tubes coming out of it. Excuse me. The thing with these, though, is that they kind of end right behind your tongue, like here. So if you've got a permanent retainer, like I do, you also, again, have issues with plaque building up on that permanent retainer because it's one of the entryways for this saliva. Excuse me. So, saliva. We make about 1 liter to 1.5 liters of saliva a day. That's how much we actually make. The serous portion is produced by the parotid and the submandibular glands. This is the liquidy kind that we make, okay? It contains the digestive enzyme salivary amylase. Remember, anything ending in ACE is going to be an enzyme. Salivary amylase is going to be a starch enzyme. It breaks the covalent bonds in polysaccharides. It only really does about 3 to 5% of the digestion of carbohydrates, but it still helps. If you take a very small piece of like white bread or a roll and you put it in your mouth, eventually you end with white goo. And a lot of people, I think, well, it's because it got wet. It's because of the salivary amylase starting that breakdown. Now, admit it, it's not going to like take it all away because it doesn't sit in your mouth that long, but excuse me, it does begin that process. It also prevents bacterial infections because it rinses the oral cavity. You're constantly producing new saliva and swallowing, so it's not stagnant. Now, does this mean you don't have to brush your teeth? No, brush your teeth. That's gross. Okay. Lysozyme. This is also an enzyme. Lyse means to break, right? So lysozyme is a weak enzyme that's in your mouth that can actually help to kill foreign invaders. And then you also have antibodies present in the serous portion, immunoglobulin A, okay? So the mucus portion is produced by the submandibular and the sublingual glands. This contains mucin, okay? This is that proteoglycan that I've talked about forever that basically holds on to water, okay? So you may be going, okay, but why is that important? Why do I have to hold on to water? Instead of thinking about the function of eating, think about, let's say, the function of working out. And as you're working out, you're, if you're like me, you're like, I'm dying, right? Breathing like that dries your mouth out really, really quickly, especially if your saliva is very, very watery. Making it thick and viscous means that it sticks around better. And so the I guess so. The mucus portion of your saliva, that thickened saliva, actually helps to keep your mouth lubricated without evaporating so quickly. So it's got that mucin in it. Now, your parasympathetic and your sympathetic nervous system will stimulate the salivary glands. If you want more information on that, you can get more information on that. But pretty much, if I'm running away from a predator, right, and I'm probably going to be producing more of a mucus saliva. If I'm, sitting, eating popcorn, watching Dancing with the Stars, probably going to be producing the serous saliva, the liquidy one, that'll help me to moisten the food, give me enzymes to digest it, and allow the molecules, the tastant molecules, to suspend in fluid so that I'll be able to taste them. Okay, so next in line after the mouth is the pharynx. The pharynx is going to be this tube right here. Okay, I'm sorry, that's the esophagus. The pharynx is going to be this part of the tube up here. So it was mentioned in the respiratory system that there's a piece of this behind the nose, behind the mouth, and then the upper part of the throat. So you have the nasopharynx, the oropharynx, and the laryngopharynx. When it comes to digestive system, the only two that participate are going to be the oropharynx and the laryngopharynx. They're the only parts that do, unless you're taking food in through your nose, which is weird. Don't do that. It's gross. then your nasopharynx ain't gonna be doing anything in this system. With that in mind, okay, understand that those two parts of your pharynx are going to be stratified. They're going to have multiple layers of cells. Everybody's had that one Dorito, don't lie. Right? I didn't chew it well enough. Everybody's had the one Dorito. But having all of those extra layers of cells, having that stratified squamous in there, actually means that when you do that, have that one Dorito, it's not necessarily going to do a whole heck of a lot of damage, hopefully. Also, right here, at the laryngopharynx, you've got the epiglottis. The epiglottis, when you are eating and food comes, basically folds over your breathing tube to prevent food from going into that tube. So the esophagus itself is a collapsible muscular tube, and it connects your pharynx to your stomach, okay? Its job is to carry food from point A to point B. That's it, okay? You've got two sphincter muscles. You've got an upper esophageal sphincter that is actually skeletal muscle, which means that it's voluntary. Basically, it controls movement from the pharynx to the esophagus. Then you've got the lower esophageal sphincter. This is made out of smooth muscle. You do not control this muscle, okay? You have no control over smooth muscle. I will say it until the day I die. If I had control over smooth muscle, I would be a lot thinner. Just saying. Okay, so the second sphincter, the lower esophageal sphincter, is going to control movement from my esophagus into my stomach, okay? The layers include the same layers we were just talking about. You've got the mucosa, the submucosa, the muscularis, which has a circular layer and a longitudinal layer. And then you've got the outer layer that is the adventitia. So I know I mentioned serosa earlier, so that's kind of confusing. Let's talk about that. Serosa is the outer layer in the abdominal cavity. The esophagus is going to be up here in the thoracic cavity, so that outer layer is now called the adventitia instead of the serosa. Once you hit the stomach, though, it's serosa from that point down, okay? Something else to keep in mind. This note right here. There is no digestion happening in the esophagus. The esophagus has nothing to do with digestion at all. It literally is there to take things from point A to point B. If there are some leftover enzymes that have been left over from your saliva, there may be a little bit of digestion happening, but major digestion because of something the esophagus is doing, It's just taking that bolus of food, that thing you swallowed, from your pharynx to your stomach. The end. Okay? So let's talk about swallowing, the process of deglutition. Fancy. There are three phases to this: the voluntary phase, the pharyngeal phase, and the esophageal phase. Okay? So during the voluntary phase, the bolus is pushed against the hard and soft palate of your tongue, going posterior, going toward the back of your throat to the oropharynx. So you've chewed it and now it's getting pushed back this direction, okay? So that's the voluntary phase. In the pharyngeal phase, the soft palate here gets elevated and it closes off the nasopharynx. It closes off the nose so that food doesn't come out of your nose. The pharynx and the larynx actually get pushed up. And as this gets pushed down, you've got constrictor muscles forcing that food into the esophagus. As that happens, the vestibular and vocal folds expand medially. It actually closes your vocal cord area, your larynx. Okay, it seals that tube. The epiglottis, this little piece right here, actually bends over so that the food doesn't go this way, this gets covered up and then it goes back this way. Something you have to understand about the esophagus. The esophagus is not really a tube. It's more like a deflated balloon until there's food in it. Once food is in it, it'll expand. But when there's nothing in it, it just deflates like a balloon. There's no reason to have it open. Finally, we've got the esophageal phase. The esophageal phase is when the esophagus actually starts to squeeze that food down to get to your stomach. Okay? Give me 1 second. I need to find a video that I want to show you real quick. All right. Hang on a second. So I'm in between using 3 separate computers, and I had to find which computer this video was on. I'm sorry it took so long. Well, for you, it was probably just a second, right? Okay. So if you watch the video, you'll notice that his tongue is moving from side to side and cheeks are pushing that food in between his teeth. Tongue pushing in between, cheeks pushing back so that it's actually sitting where it's supposed to in between the teeth while I chew. There's the uvula going up, blocking the nose. Here's the esophagus, epiglottis coming down to block your breathing tube. So here's your breathing tube. Okay, so here's your trachea. So this right here is the epiglottis that folds over. This is the esophagus back here. Notice that it's completely collapsed, right? So when the tongue pushes up and back, this pops up. This is that dangly thing in the back of your throat, the uvula, that pops up to block your nasal cavity up here. Okay, so I'm going to play it again without me being in the way, so hopefully it shows up really well. I will load this video up onto Blackboard so that you can see it on your own computer. You'll also notice that the throat actually does kind of contract upward for that fold to happen. You'll notice that it pops up right here. Okay? And if you are swallowing anything, you can actually feel that. You can put your hands up against your throat like this and swallow, and you'll feel this pop up just like it did in the video. Okay, so next in line after the esophagus is going to be your stomach. This is kind of an enlarged segment of that digestive tubing, the digestive tract, in this left superior abdomen. Shape and size can vary. Your stomach is made out of some very elastic tissue. So if you're used to eating really, really huge meals, your stomach stretches out. Anybody who's ever had any type of gastroenteritis, like a stomach bug, or you've had food poisoning, which is gastroenteritis, but just go with me on it. You'll know that after days of not eating anything because you vomited, that when you start eating again, it's not like you can eat as much as you once did. And that's because your stomach actually shrank back down because you weren't eating as much. So looking at the stomach, okay, the stomach has several different parts and pieces, but you can see where the esophagus is entering the stomach right here. So that lower esophageal sphincter can also be called the gastroesophageal sphincter. If you see gastro anywhere in A&P, it's referring to the stomach, okay? If you see esophageal, it's the esophagus. If you see hepatic or hepato, that's going to be the liver. Cystic would be the gallbladder, just so you know. Okay, so the esophagus goes down into the stomach. You've got that gastroesophageal opening. This part of the stomach actually sits right under the diaphragm of where your heart is. So they tend to call this area the cardiac part of your stomach. You've got this kind of bulby portion that kind of comes above that. That's called the fundus. The main part of the stomach is going to be called the body. And here's my serosa, that outer layer that we talked about at the beginning. So you've got 3 layers of muscle. Remember I said everywhere has 2 layers except for the stomach, right? So you've got the longitudinal, you've got the circular, but then you've got kind of this oblique layer. So again, you've got the longitudinal, you've got the circular, but then you've got a layer that kind of does this. It kind of goes angular. And one of the reasons is because your stomach moves a lot. It's not just pushing the food through or squeezing it like it happens in the intestines. There's a lot more movement here, okay? So you've got all of these layers. The inner layer is going to be, of course, your mucosa, and you've got the submucosa outside of that between the oblique layer and the mucosa on the inside. You will notice that your stomach lining looks very wrinkly. You may notice that, you may not, because it's whited out on your screen. Come on. Don't look at me, look at the stomach. Maybe if I come over here. Come on, camera. Okay. And bring this up here. Hang on. All right. Sorry. You'll notice that there are wrinkles in the stomach. Those are called the rugae, okay? And they're there so that your stomach has the capacity to expand when you eat. You'll also notice that you've got kind of a small curve and a large curve just based on that kind of paisley shape of your stomach. The smaller curve is called the lesser curve. The bigger curve is called the greater curve. Now, as you come to this end of the stomach, you'll notice that it kind of starts looking like a funnel. It starts to kind of funnel down here, okay? As it does that, we call that the pyloric part of your stomach. We call that the pyloric part of your stomach, okay? It starts with the pyloric antrum, and then right before it actually exits, you've got this kind of canal, this pyloric canal here, where it really, really narrows. This hole that normally isn't there is called the pyloric orifice, and the muscle that controls the exit of things from your stomach into the beginning of your small intestine, the duodenum, is the pyloric sphincter. So these are all the parts and pieces of your stomach, okay? Sorry about closing that and losing you for a second.